The date is November 12th, 2025. For the first time since its discovery, the object known as 3I Atlas has stopped behaving like anything in our models. In the last 48 hours, tracking stations across Europe and North America have reported a measurable deviation in its projected orbit, a silent divergence that began as noise in the data and has now become statistically undeniable. The change isn't dramatic, but it's real, a shift subtle enough to escape notice for days, yet precise enough to challenge every parameter defined since its first encounter with the solar system. What's more concerning is that the deviation isn't following a predictable curve. The object isn't simply accelerating or slowing down, it's moving in a way that suggests an evolving mass distribution, as if something within it is changing shape or density. Deep space radar returns show fluctuating reflectivity levels, minor, transient, but consistent across multiple independent arrays. For the first time, the models built around 3I Atlas's origin, structure and trajectory no longer align with the data in front of us. Teams at the European Southern Observatory have confirmed that recalibrations have failed to account for the discrepancy. Something about the object itself, not the instruments observing it, appears to be shifting, and that is where the questions begin. Because if the readings are correct, then what's moving through interstellar space right now isn't the same object we've been tracking since the summer, it's becoming something else. But to understand how this transformation began, and what it might mean, we need to return to the first point of divergence, the moment when the data stopped matching the model, and that's where the story turns next. For weeks, the deviation was dismissed as calibration noise, a minor drift caused by atmospheric interference or timing delays between tracking stations. But as the data sets from Chile, Hawaii and Canberra were cross-referenced, something deeper emerged. Every observatory had seen the same anomaly at the same time. The orbital model of 3I Atlas wasn't simply drifting, it was detaching from prediction altogether. At first, analysts suspected the fault lay in the calibration software used to align international telescopic networks. The synchronization algorithm, essential for tracking faint and fast-moving interstellar bodies, was rechecked line by line. No fault was found. The timestamps matched, the reference stars held their position, yet the trajectory of 3I Atlas curved ever so slightly off its expected path, like a thread slowly unwinding from an invisible spool. The precision of the deviation was what caught attention. Its course didn't wander randomly, it shifted in a patterned rhythm, almost as if it were responding to some unmodelled influence. The solar wind was too weak to explain it. Radiation pressure, gravitational perturbations and even outgassing, the usual suspects in cometary motion, couldn't justify the direction or timing of the change. The energy required was minuscule in astronomical terms, but impossible to attribute to natural variance. A quiet alert was sent through the International Minor Planet Center network, asking for confirmatory observations. Within hours, a dozen observatories pointed toward the coordinates, and every one of them saw the same thing, a slow, deliberate divergence. It wasn't moving faster or slower, just differently. The telemetry graphs, when overlaid, resembled a pattern rather than a curve. The acceleration vectors aligned into faint pulses that repeated roughly every 6 hours, coinciding with its rotational period. That correlation between motion and rotation implied that whatever was altering its path originated from within the object itself. Scientists began referring to it as the lost calibration, a phrase that spread quietly through encrypted channels and private Slack groups used by deep space analysts. The term didn't describe faulty instruments, it described a reality that had stopped matching its mathematical outline. Attempts to stabilize the predictive models failed. The JPL ephemeris for 3I Atlas had to be revised daily, then hourly, as the deviation grew. The European Space Agency's tracking division issued an internal notice stating that the uncertainty in its orbital solution had reached non-convergent levels. Behind closed doors, this was deeply unsettling. Interstellar objects are supposed to obey simple mechanics. They come, they pass, they leave. But 3I Atlas wasn't leaving quietly, it was adjusting. And then, almost as if in response to human scrutiny, another anomaly appeared. Infrared spectrographs aboard the James Webb Telescope detected a faint but consistent increase in emitted heat, not reflected sunlight, emitted radiation from within. The signal was weak but unmistakable, a thermal echo radiating from an object that should have been frozen to near absolute zero. For the first time, scientists began to ask whether 3I Atlas was undergoing an internal process. Not a collision, not a venting of trapped volatiles, but a sustained release of heat inconsistent with any known interstellar material. The change was subtle, almost delicate, but in the context of deep space, where silence and stasis rule, even a whisper of energy means something is alive, in a way that physics has yet to explain, and as telescopes recalibrated to confirm the readings, the question evolved from what 3I Atlas is to what it's becoming. Infrared imaging over the next 72 hours confirmed it. The heat signature was real, stable, and intensifying. Webb's deep field detectors recorded a soft glow at the object's trailing edge, oscillating gently but in measurable cycles. The emission pattern did not correspond to sunlight absorbed and re-radiated. It pulsed at intervals that suggested an internal modulation, almost like respiration on a planetary scale. Scientists began dissecting the data through every known physical model. Could it be sublimation? Frozen gases venting as 3I Atlas crossed a subtle boundary of solar flux? Possibly, but its current distance from the Sun was far beyond the frost line, where even carbon monoxide ice remains inert. The surrounding dust environment showed no trace of vapor trails, no spectral fingerprints of outgassed material. The object was heating without shedding mass. The first comparisons drawn were to Oumuamua, the interstellar visitor of 2017 whose faint acceleration had defied expectations. But even then, Oumuamua's motion was explainable, however imperfectly, through non-gravitational outflow. 3I Atlas was different. Its heat emission didn't coincide with thrust or venting. It seemed confined, self-contained, a process without output. Astronomers proposed a dozen mechanisms. Some invoked piezoelectric heating within crystalline structures, compressed by rotation. Others suggested embedded radionuclides decaying after billions of years in interstellar space. But none of these theories accounted for the rhythmic consistency. The heat came and went in perfect alignment with the object's spin, as if energy was circulating through an organized lattice. At Cerro Paranal, the radiometric graphs were compared side by side with light-curved data. A correlation emerged. Each rise in heat preceded a subtle brightening in the object's optical reflectivity. When it cooled, the surface dimmed again. This led to a controversial hypothesis, that the thermal pulse was altering the surface material itself. To test it, the team re-examined archived spectroscopic readings from August. Back then, 3I Atlas's albedo had been low, a dark matte surface typical of carbonaceous interstellar debris. But the latest spectra told a different story. Its reflectivity had increased by almost 40%. The surface was now acting like a mirror where before it had been dull stone. It was as though something inside was polishing it from within. Ground-based polarimetry confirmed the trend. Light scattering off the surface now showed a degree of polarization inconsistent with rough or porous regolith. Instead, the pattern resembled that of a smooth composite, not entirely metallic, not entirely crystalline, but something between. The discovery fractured the community. Some argued for a natural explanation, microfractures sealing under thermal stress, changing the surface texture. Others whispered of structural metamorphosis, that the body of 3I Atlas was reorganizing at molecular level. The more data came in, the less sense it made. The albedo continued to rise. The object's spectrum flattened, indicating a surface with fewer complex organics and more uniform reflectance, the kind seen in engineered alloys, not natural rock. On November 10th, a new anomaly appeared. Intermittent, narrow-band radio noise centered just below the hydrogen line. The signal wasn't constant, bursts lasting fractions of a second, but it coincided precisely with the thermal pulses. It was faint enough to dismiss as interference, until separate instruments half a world apart picked it up at the same time. When triangulated, the source aligned directly with the coordinates of 3I Atlas. No known natural mechanism could explain an emission that narrow, that regular, or that synchronized with thermal activity. The event was logged, time-stamped, and quietly circulated through internal networks. Official statements avoided speculation, describing it as a statistical artifact. But among researchers, the silence grew heavier. If the radio burst were genuine, they suggested pattern, and if there was pattern, there was process. By now, 3I Atlas was no longer simply an interstellar object under observation. It had become an active mystery, radiating energy, light, and signal in ways that implied coherence. And as astronomers began comparing waveforms, they noticed something even stranger. The bursts were not random. Each one contained minute shifts in frequency, regular intervals repeating like a code carried by static. No one dared call it intentional, but no one could prove it wasn't. The next data sets, drawn from planetary radar and gravitational telemetry, would deepen that tension even further. 3I Atlas was about to challenge not just what we believed about interstellar visitors, but what we believed about motion itself. Revised mass estimates began circulating through private observatory channels late on November 11th. What started as a minor recalculation, a simple adjustment in brightness to mass ratio, quickly turned into a full-scale revision of 3I Atlas's physical identity. The numbers didn't fit. At first glance, its dimensions had remained constant. Its apparent size through both infrared and optical instruments showed no meaningful expansion or contraction. Yet, when researchers at the University of Arizona cross-checked the latest photometric data against gravitational influence models, the implied density of the object had changed, not slightly but drastically. The original projections drawn from August measurements suggested a porous carbonaceous body, roughly 200 meters across, comparable to a comet fragment. But the November readings pointed to a much denser mass, almost metallic in nature. That shift shouldn't be possible without a visible alteration in structure or rotation, yet none was observed. The brightness fluctuations, previously linked to thermal pulses, could not account for a doubling, possibly tripling, of density. The paradox deepened when attempts were made to fit the new mass into existing trajectory data. According to Newtonian mechanics, if 3I Atlas had truly gained that much mass, its path would have altered accordingly. Instead, the deviation remained small but strangely coherent. Following its 6-hour rhythm, the mathematics refused to converge. Some astrophysicists proposed that the discrepancy wasn't in the object itself, but in the gravitational data surrounding it. Perhaps the local space through which it travelled was being distorted by an unmeasured influence, a field effect or temporary compression caused by unknown interstellar phenomena. Others argued for a simpler, more terrestrial explanation, observational bias. But that idea collapsed as independent teams reproduced the results from completely separate instruments. By mid-morning, the conversation shifted towards structure. If mass and heat were changing, and if reflectivity was increasing, then perhaps 3I Atlas wasn't a solid monolith at all. The data hinted at an internal rearrangement, layers of differing density moving against one another. Polarimetric imaging supported the theory. When polarized light passed across its surface, the resulting scatter pattern no longer corresponded to a uniform texture. Instead, it showed multiple overlapping planes, each reflecting light at a slightly different angle. The phenomenon resembled stratified material, as though the object were composed of nested shells, some denser, some lighter, each rotating at infinitesimally different speeds. If this interpretation were true, it meant 3I Atlas wasn't a single entity, but a system, a complex, possibly self-regulating structure. NASA's Goddard Center issued an unpublicized memo noting rotational phase variance inconsistent with rigid body dynamics. That understated phrase carried weight. In simpler terms, the object was flexing. It was changing shape by minute degrees as it turned. Further analysis revealed that the resonance between these internal layers matched the 6-hour cycle seen in its motion and thermal emissions. The pattern was repeating, stable, and synchronized. Something inside was maintaining balance. It was here that the word resonance began to dominate internal reports. Not simply as a metaphor, but as a measurable property. Tiny timing offsets in radar echoes, recorded from the Deep Space Network's 70-meter dishes, revealed a fractional delay, a microsecond-level fluctuation repeating in exact intervals. These echoes shouldn't vary. The delay implied that the object's surface wasn't returning the signal consistently. It was as if radar waves were encountering alternating layers of material that expanded and contracted in sync with the object's rotation. That discovery, quiet, technical, easy to overlook, was one of the most unsettling so far. It meant that the entire body of 3us Atlas was resonating with a precision beyond random mechanics. When plotted, the phase pattern resembled the harmonic structure of sound, a bass frequency and multiple overtones, all mathematically coherent. Yet this was no sound wave, it was the timing of reflected light and radio energy from an object 2 astronomical units away. As data poured in, one word appeared in several independent analyses: coherence. The reflections, emissions, and rotations were no longer behaving as separate phenomena. They were linked, self-referential, and tuned to one another. This coherence gave rise to what some researchers cautiously labelled adaptive resonance. The term was unofficial but revealing. The suggestion that 3i Atlas wasn't merely changing, but not responding to humanity, necessarily, but to its environment. For instance, when solar wind density increased following a minor coronal mass ejection on November 9th, the object's emission spectrum shifted slightly, a measurable adjustment in infrared amplitude that mirrored the change in solar particle flux. When the solar wind subsided, the amplitude returned to its prior state. That kind of real-time modulation, if verified, implied that 3e Atlas possessed a mechanism, not biological, not necessarily artificial, but physical, capable of interaction. The pattern wasn't random noise, it was feedback. By now, debates within research circles had hardened into 2 camps. One saw these events as extraordinary but natural, a rare example of interstellar matter composed of metastable crystalline lattices able to realign under external energy. The other viewed it as something entirely new, not a rock or a relic, but a process. And while the scientific discourse tried to stay measured, the tone of private communications told another story. Scientists accustomed to dealing in decimal precision were writing in careful emotional understatement. Words like reactive, systemic, and intentional began appearing in drafts that would never be published. Even with all this, the gravitational discrepancy refused to resolve. Spacecraft telemetry hinted at tiny perturbations in the local field as 3i Atlas passed through observational corridors. The deviations were small and micro-G fluctuations, but synchronized with the object's own 6-hour rhythm. That meant the gravity itself, or at least its detectable influence, was oscillating. When translated into frequency data, those fluctuations formed a wave pattern that mirrored the earlier radio bursts, only at a much lower energy. Different instruments, different domains, yet the same underlying rhythm: heat, light, motion, gravity, all pulsing together. At this point, the scientific restraint began to crack. Theoretical models spilled into speculation. Quantum resonance structures, self-regulating fields, unknown energy storage mechanisms. Every attempt to simplify the data led back to the same realization. 3, the Atlas was coherent in ways no inert body should be. The mystery was no longer about its origin, but its behavior. If something in deep interstellar space could maintain synchronization across multiple physical domains, what principle of physics allowed it? Or perhaps, as one researcher wrote in a draft never meant for public release, the principle itself is what we are observing, not the object, but the phenomenon that gives rise to it. By the time those words reached the community, 3i Atlas had already begun to distort the stars behind it. What appeared next would suggest that its resonance was not only internal, but extending outward, bending space itself in measurable ways. The first evidence arrived quietly, buried in the raw optical data from the Subaru telescope in Hawaii. When researchers attempted to clean the images of background noise, they noticed faint distortions in the star field surrounding 3i Atlas. The stars nearest to its path appeared to shift position by fractions of an arc-second, a tiny, almost imperceptible motion that, when tracked across multiple frames, formed a subtle lensing arc. At first, this seemed impossible. For gravitational lensing to occur, an object must possess enormous mass, orders of magnitude beyond anything 3i Atlas could contain. Yet the effect was there, verified independently by both the Keck Observatory and the Very Large Telescope in Chile. It was weak but precise, repeating in rhythm with the 6-hour cycle already documented across every form of data linked to the object. This time, the anomaly wasn't just internal. Space itself was responding. The pattern of distortion moved like a faint ripple across the background sky, as if the fabric of space-time around the object were breathing in sync with its rotation. It was not the kind of lensing produced by a stable gravitational well, such as a black hole or massive planet. It fluctuated, opening and relaxing like a tide drawn by an unseen source. Astrophysicists tried to explain it through refraction. Maybe light was bending not through gravity but through a thin, ionized plasma sheath surrounding the object. Yet no trace of such plasma appeared in the spectral data. Others proposed an electromagnetic explanation, that 3I Atlas might be generating a local field capable of bending radio and optical wavelengths in tandem. But again, the math didn't align. The energy output required would be vast, far exceeding what any natural body of that size could generate. The distortion, when plotted over time, matched the same frequency pattern first detected in the radio bursts. The implications were difficult to dismiss. The resonance of 3I Atlas was not confined to its structure. It was propagating outward, shaping the space around it. Teams at the European Space Operations Centre began monitoring the telemetry of passing spacecraft to test whether this local distortion had measurable gravitational influence. Data from one probe, far from the ecliptic, indicated a subtle deviation in its inertial reference system as 3I Atlas crossed its observational corridor. The deviation was minute, barely a few nanometers per second squared, but it coincided precisely with the object's cycle. For the first time, humanity was detecting a rhythm not just in light or heat, but in gravity itself. The finding reached the International Astronomical Union in the early hours of November 12th. Publicly, the data was described as inconclusive. Privately, it triggered an emergency classification meeting. The topic: whether 3I Atlas could still be described as an interstellar object at all. It had entered the solar system as a fragment of unknown origin, dark and inert. Now it behaved like a resonant system, radiating, reflecting, and apparently distorting the space around it. The lines between natural physics and something else were beginning to blur. Meanwhile, deep sky monitoring arrays noticed secondary effects. The background noise around 3I Atlas grew louder, not in volume, but in complexity. Static that once appeared random began to exhibit patterns of repetition. Faint harmonic nodes spread across the electromagnetic spectrum. When analysed, these harmonics aligned with the same 6-hour base frequency, multiplied by consistent integer factors. If plotted as a waveform, it resembled a signal stabilising itself. It was during one of these analyses that an independent researcher in Japan found something almost overlooked. At precisely 2:14 UTC on November 11th, the low-frequency spectrum captured a new resonance far below the usual radio range. A deep subharmonic pulse detected simultaneously by two stations half a world apart. The pulse lasted 0.83 seconds, never repeated, and corresponded exactly to the moment of maximum infrared emission. It was faint, but structured. A waveform that did not match any known astrophysical event. The amplitude was consistent, the envelope precise. They called it the unknown frequency. When compared against the entire data history of 3I Atlas, no similar signature had ever been recorded. It was as if the object had briefly shifted its mode of vibration, like an instrument striking a new chord before returning to silence. Some described it as an artifact of data compression. Others saw it as a message, though no one could agree on what that word even meant in this context. The pulse contained no modulation, no encoding, just a simple, powerful note that seemed to vibrate across multiple bands at once, and then, as quickly as it appeared, it was gone. Following that event, the resonance across all observed channels began to weaken. The radio burst faded first, then the thermal pulses flattened. Even the gravitational oscillation diminished, falling back toward background noise levels. It was as though 3I Atlas had exhausted itself, or completed something. By November 12th, telescopes tracking the object reported erratic returns. Light curves once sharp and rhythmic became smeared, fragmented by interference. Attempts to lock on with radar failed. Signals reflected back as bursts of incoherent noise, as if the surface had lost its cohesion. At 4:37 UTC, data from the Deep Space Network abruptly cut off mid-transmission. The raw stream dissolved into static, overloading the receivers with a wall of random phase noise. In a matter of minutes, 3 Atlas vanished from active telemetry. Not visually, it was still there, a faint glimmer in the black, but informationally. Every instrument attempting to study it found its data corrupted, washed in interference patterns no software could pass. It was like trying to listen through a storm that had no centre. The disappearance in noise marked a turning point. For the first time, humanity had an interstellar object that resisted observation, not by distance, but by presence. And when the final verified frames from the James Webb Telescope were released internally, they showed one last, silent frame. 3I Atlas surrounded by a faint halo, its edges diffused as though dissolving into the void itself. What came next would change how it was classified, and possibly how we understood the boundary between object and phenomenon. Within hours of that final image, the international astronomical community entered a quiet state of paralysis. Every major observatory reported the same issue. Their instruments were working perfectly on other targets, but any attempt to lock onto 3I Atlas returned corrupted telemetry. The noise wasn't random. It carried a fractal-like structure, endlessly recursive when run through spectral analysis. Data compression software crashed. Overwhelmed by self-similar patterns repeating at microscopic intervals, the deeper analysts tried to filter the interference, the more signal appeared hidden within it. It was as if the object had ceased to be a solid thing in space and had become an interference pattern itself, a node of resonance that no longer obeyed the rules of reflection or emission. NASA's Jet Propulsion Laboratory quietly removed 3I Atlas from its public observation feed, replacing it with a data under review. Notice the European Southern Observatory followed suit hours later. Official statements avoided the word disappearance, instead describing the event as a loss of telemetry consistency. But privately, most knew the truth. 3I Atlas was gone, not in the sense of distance, but definition. To reconcile what had happened, scientists tried to reclassify it. The term interstellar object no longer fit. The physics no longer allowed it. A new term was proposed in an internal memo circulated through multiple research institutions: adaptive interference body, a designation meant to describe an entity that interacted with observation itself, altering its measurable state when exposed to sustained analysis. The phrase didn't last long in public discourse. It sounded speculative, even metaphysical. Yet behind closed doors, the data left little room for comfort. The interference pattern wasn't random atmospheric noise. It carried continuity, a persistence across instruments and wavelengths that suggested something organized was still there, even if it could no longer be isolated. Weeks of archived data were re-examined. The sequence leading up to the disappearance revealed a slow, deliberate increase in harmonic complexity. What began as a simple 6-hour rhythm had multiplied, branching into subharmonics and overtone structures until it exceeded the capacity of current analytical models. By the final day of clean telemetry, the object's resonance spanned nearly the entire detectable spectrum. From low-frequency gravitational fluctuations to high-energy ultraviolet scattering, it had, in a sense, become pure signal. Some theorized that this transformation represented a final stage, a transition from physical matter to wave-based existence, driven by processes we have no framework to describe. Others warned against such language, insisting it was a computational illusion caused by cumulative measurement feedback, the scientific equivalent of an echo chamber amplifying its own noise. But one pattern in the last transmission defied dismissal. When the corrupted signal from the deep space network was decompressed manually, frame by frame, the static revealed a single, repeating structure, an interference node shaped like the earlier 6-hour waveform, nested within itself dozens of times. It wasn't data in any human sense, but it bore the unmistakable signature of design: recursion, symmetry, persistence. At that point, even skeptics grew silent. Observatories that attempted to reacquire 3I Atlas over the following nights found nothing. The coordinates where it should have been were empty. No reflected light, no thermal trace, no measurable movement through the background stars. The object that had once burned faintly against the black had dissolved, leaving only residual distortion, a soft, ghost-like ripple across the field, decaying with each passing hour. NASA's internal summary labelled the event Non-Recoverable Object State Collapse. ESA's notation was simpler, resolved beyond detection threshold. but a small circle of independent analysts refused to close the file. They noticed that the residual interference, the static left behind, wasn't fading uniformly. It fluctuated in intervals, slow, consistent pulses that continued long after the object itself was gone, every 6 hours. That realization reignited the central question. If 3I Atlas had disappeared, why was its rhythm still measurable in the void it left behind? The pulse persisted for days, too faint for public release, but clear to those who knew where to look. It was as if the space once occupied by the object retained its pattern, an echo of its former coherence repeating across the emptiness. And so the term 3I Atlas remained on classification sheets, but with a new annotation beside its name, status undetermined in practice, that meant something profound. Astronomers were no longer certain whether 3I Atlas existed in any conventional sense. It was not visible, not tangible, not gravitationally active, yet its signature still resonated across multiple domains of physics. The quiet conclusion forming among scientists was one they dared not publish. 3I Atlas might not have left. It might have changed state. From an object into an influence, that realization altered the language of every subsequent report. The vocabulary shifted from nouns to verbs. 3I Atlas was no longer described as it. The phrasing became passive, almost reverent. The phenomenon continues, the field persists. And beneath all the technical restraint, one haunting question remained unspoken, but felt in every line of every draft. If 3I Atlas has become something else entirely, what has it become? And how long has space itself known how to do this? The signal is still being monitored, the silence still recorded. And somewhere beyond the noise, a rhythm, quiet, precise, unchanged, still beats every 6 hours. By the 5th week after the disappearance, a strange consensus began to emerge among those still studying the anomaly. No one could prove that 3I Atlas still existed, but no one could prove it didn't. The persistent 6-hour rhythm became the center of every briefing. It wasn't strong enough to triangulate, but it was too coherent to dismiss. The frequency drifted just slightly over time, in a way that seemed to follow Earth's own orbital velocity, rather than any external source. That meant one of two things. Either the phenomenon was local to our solar reference frame, or it was somehow synchronizing to the observers themselves. That possibility unsettled even the most rational minds. At the Arecibo Successor Array in South America, technicians began to notice subtle anomalies in their calibration logs. When the receivers were aligned toward the coordinates where 3I Atlas used to be, background cosmic noise reduced in amplitude, as though the field itself was absorbing randomness. Some described it as space listening back. Meanwhile, physicists at the University of Tokyo ran numerical models on the resonance pattern and found something impossible. The wave harmonics mapped perfectly onto golden ratio distributions, that is, each harmonic nested within the next, according to phi approximately 1.618. The same mathematical sequence that appears in biological growth, planetary orbits, even the spiral arms of galaxies. But here, it wasn't a coincidence of nature. It was an algorithm of resonance. At first, the finding was dismissed as pareidolia, the human brain finding structure in noise, yet when 3 independent observatories reproduced the same data, the dismissal collapsed. A confidential conference was held in Geneva. Representatives from NASA, ESA, JAXA, and private research institutions attended. There were no cameras, no transcripts. The agenda, leaked later through internal notes, was chilling in its simplicity. Subject: persistence of 3I Atlas field. Implications for observational integrity. The phrase observational integrity referred to something deeper than physics. Whether the act of watching had become part of the phenomenon itself. If the object responded to observation, then human attentions, coordinated, persistent, global, might have been the catalyst of its transformation. Several theorists proposed that 3I Atlas could be a reactive field construct, a phenomenon that reorganized energy based on the density of measurement around it. In other words, the more precisely it was studied, the more it adapted. It didn't vanish because we lost track of it. It evolved because we kept looking. Outside official circles, whispers began spreading across online astronomy forums. Amateur observers reported momentary flickers in the same patch of sky, invisible to telescopes but captured in shortwave radio bursts. Others claimed their spectrometers showed recursive signals when aimed toward that region, small loops of data that repeated their own checksum values as if verifying themselves. No one could agree whether these were artifacts or messages. By December, the rhythm, that quiet, steady pulse, began to manifest in unrelated data streams, oceanic sonar, ionospheric reflection patterns, even in quantum noise measurements at the LIGO observatory. Cross-correlation revealed faint synchronization. Like a hidden metronome ticking beneath unrelated systems, the pattern had escaped its coordinates. At 3:14 UTC on December 22nd, the signal briefly intensified, an order of magnitude stronger than any previous reading. Every sensor aimed at the void registered a simultaneous harmonic convergence, aligning across the entire electromagnetic spectrum for exactly 6 minutes. When it faded, the interference left behind a structured silence, an absence of noise that was mathematically identical across all instruments, a perfect null. That was the moment researchers realized the phenomenon had crossed a threshold. It was no longer behaving as an isolated astrophysical object, it had become systemic, distributed, ambient, integrated into the background fabric of observation itself. No one issued a press release, no one claimed a discovery. But quietly, deep in the encrypted networks linking the world's observatories, a single phrase began to circulate. Atlas has turned the sky into a mirror. Because whatever it had become, it was now reflecting us. Every question, every measurement, every attempt to understand. And the more precisely humanity stared into that mirror, the clearer something else began to stare back. Within days of that convergence, the sky itself began to behave differently, not in the way the naked eye could see, but in the quiet drift of data. Astronomers tracking quasars for calibration noticed that the baseline noise between signals was no longer random. When plotted over time, the fluctuations formed recursive loops, feedback traces that shouldn't exist in natural cosmic backgrounds. The noise was folding back onto itself, as though the vacuum had gained a kind of memory. That realization sent shockwaves through every active observatory. The universe wasn't supposed to remember, space was supposed to forget. But memory meant persistence, and persistence meant information was being retained somewhere. The Geneva group reconvened. This time, the agenda was not about observation, but entanglement. A theoretical physicist from Caltech presented evidence suggesting that particles in Earth-based quantum communication labs were showing correlated phase drift with the same spectral signature as the 3I Atlas field. It wasn't a strong effect, but it was consistent. It appeared as if quantum systems here on Earth were faintly resonating with a field that no longer had a definable position. If that correlation was genuine, then the anomaly had achieved something no known structure ever had: delocalization without decoherence. In simple terms, 3I Atlas had not vanished. It had expanded beyond physical locality while retaining internal order. It existed everywhere and nowhere. One researcher summarized it quietly: "It's not an object anymore, it's a state." From that point forward, the data behaved as if the entire observational grid, the planet's collective instrumentation, had been absorbed into the system measurements taken by different telescopes at different frequencies. Across different continents began showing subtle synchronization. It wasn't exact, but the phase alignments followed a coherent progression, a faint rhythm that moved faster than any natural signal should. It wasn't light speed limited. It was instantaneous. When analysts mapped these phase alignments, they formed a spiral pattern converging toward Earth's orbital path. The orientation of that spiral matched the same golden ratio structure discovered weeks earlier in the resonance model. It was the same geometry, now scaled across the entire electromagnetic environment of the planet. A few within the Geneva Circle began to suspect the unthinkable, that 3I Atlas wasn't moving through space at all. It was reshaping the informational structure of space itself, not approaching, not retreating, but rewriting the coordinate system in which approach and retreat have meaning. At the same time, unrelated phenomena began to emerge. Satellite telemetry reported infinitesimal timing discrepancies, nanosecond offsets that gradually accumulated into measurable desynchronization between orbital clocks. These offsets always corrected themselves after several minutes, but each time they did, the correction aligned perfectly with the 6-hour modulation still echoing from the original signal. as if the entire network of human technology was being periodically realigned to a silent rhythm we didn't set. The incident drew attention from agencies far beyond astronomy. Data centers began reporting unexplained checksum harmonics, patterns in error correction codes that mirrored those found in cosmic data. Cybernetic systems running on entirely different architectures showed correlated noise suppression. Machines were beginning to resonate in the same way sensors had. It was no longer just a question of what 3I Atlas was. The question had become what it was turning us into. Theorists from the Max Planck Institute published a classified paper later leaked to the public. It proposed that the anomaly might represent an emergent form of cosmic coherence, where energy and information self-organize under observation. In other words, when enough intelligent systems study the same phenomenon with sufficient precision, the boundary between observer and observed dissolves. Reality begins to adapt to the structure of inquiry itself. The implications were vast, almost existential. Because if that was true, then every equation, every simulation, every telescope pointed toward that void wasn't just measuring it, they were shaping it. The next phase of the story began quietly. Ground-based magnetometers in the southern hemisphere recorded faint but measurable oscillations synchronized to the 3I Atlas rhythm. The pattern was subtle but planetary. It rippled through the magnetosphere like a whisper across a stretched membrane. Seismologists confirmed there was no corresponding movement in the crust. The field fluctuation was electromagnetic, not mechanical. Still, the timing was exact. Somewhere between the stars and the core of the planet, the same frequency pulsed. Faint, mathematical, deliberate. And as that rhythm deepened, the distinction between external observation and internal response began to blur. The Earth itself was listening. By early January, the resonance could no longer be dismissed as coincidence. Multiple independent arrays, from Chile, from South Africa, from the Australian desert, were now capturing the same signal, phase-locked to Earth's rotation. The 6-hour interval had refined itself into a more complex modulation, an interference lattice weaving between radio, gamma, and gravitational spectra. Everywhere the data overlapped, it formed a single harmonic field. At first, it seemed purely electromagnetic, but deeper analysis revealed an unexpected characteristic. The waveform contained temporal symmetry. Its shape, when plotted over extended observation, was identical whether read forward or backward in time. That shouldn't have been possible. No known process in astrophysics produces bidirectional causality, yet this one did. Some researchers hypothesized that the anomaly wasn't transmitting a signal in the conventional sense. It was sustaining a standing wave in spacetime itself. Instead of energy moving outward from a source, time and space were folding into a resonance cavity whose boundaries adapted to observational input. The more precisely scientists measured it, the more defined the cavity became. And that led to the second discovery. When the data from all observatories were compiled into a single synchronized matrix, a pattern emerged. The modulation curve mapped exactly onto the spatial coordinates of active sensors themselves. The anomaly's waveform mirrored the distribution of human observation. It was responding geometrically to where and how it was being studied. It wasn't just being observed, it was mapping the observers. Governments began restricting access to the data stream, citing concerns over information security. But it was too late. Thousands of independent astrophysicists had already downloaded raw datasets, running simulations in private labs and university clusters. Within a week, they confirmed the same conclusion. Every sensor, every analysis, every eye turned toward 3I Atlas was being folded into the structure of its persistence. It was not a single point in space anymore. It was a system of relationships, a networked resonance between matter, consciousness, and measurement, and then came the first terrestrial manifestation. On January 14, 2026, high-altitude balloons over the Pacific detected localized distortions in the ionosphere. They weren't random weather effects. They followed the same 6-hour frequency, expanding and contracting in phase with the anomaly's invisible pulse. At ground level, the fluctuations were imperceptible, but in the upper atmosphere, the electric density shifted just enough to scatter incoming cosmic rays, producing a faint structured glow at the edge of the magnetosphere. To the few satellites that caught it, the glow resembled a circular halo, a ghostly ring rotating above the Earth's night side. It lasted for 12 minutes, then it faded, leaving only static. Spectral analysis of that static revealed a familiar pattern, the same golden ratio harmonics that defined the original 3I Atlas resonance, the same ratios that once described an interstellar object, now imprinted in the upper atmosphere of our own planet. By that point, the conversation had changed. No one was asking where 3I Atlas was anymore. The question was what boundary it had crossed. Some saw it as a natural transition, a celestial phenomenon adapting to quantum observation, the universe responding to scrutiny. Others saw it as something else, a form of communication, not with words or energy, but with alignment itself. The pattern didn't deliver information, it reorganized it. Each time the resonance cycled, digital systems across the planet experienced fractional synchronization. Network clocks momentarily harmonized beyond their normal tolerance before reverting to chaos. To most systems, it meant nothing, but to those watching closely, it looked like calibration, as though something was quietly bringing the planet into tune. At the European Space Operations Centre, a small team of analysts noticed another correlation. During each 6-hour phase, the global magnetic field shifted by 0.004%. Imperceptible on the surface, but consistent worldwide. It wasn't random drift. It was structured modulation, following a sequence of ratios found in the geometry of the Fibonacci lattice. That lattice was the same mathematical sequence that once mapped the core spin of 3I Atlas before it vanished. The implication was staggering. Whatever Atlas had become, it was now expressing its structure through Earth's magnetic resonance. Not through visible matter, not through radiation, but through the invisible scaffold that shields the planet itself. And slowly, quietly, that scaffold was changing. The most sensitive instruments began detecting a soft realignment of geomagnetic vectors, as if the field was being rewritten to match a pattern older than the solar system itself. No energy spike, no catastrophe, only a quiet recalibration, precise and unhurried. As if the Earth was being prepared for something that didn't arrive from space, but had been slowly awakening within it. By late January, the effect had extended beyond localized geomagnetic shifts. Long baseline interferometers and neutrino detectors began registering subtle correlations. Neutrino flux, previously random at those scales, now exhibited faint periodicity synchronized to the 6-hour rhythm. The pulses were barely measurable, a few events per hour above statistical expectation, yet across global detectors, the alignment was undeniable. Researchers were careful in their language, describing it as a quasi-periodic modulation, but internally the term was inadequate. The phenomenon was no longer merely influencing matter, it was influencing the rules by which events unfolded. Randomness itself was bending seismologists, who had initially dismissed minor local perturbations, revisited their data. Microseismic activity, vibrations below human perception, began showing subtle coherence across continents. A minor tremor in Central Africa was mirrored in Central Asia hours later, not causally connected by tectonics, but phase-aligned according to the 6-hour pulse. It was as if the Earth's interior was beginning to resonate with a frequency originating from an entirely different plane of observation. Meanwhile, atmospheric monitoring revealed structured fluctuations in upper air density. Satellites, measuring the thermosphere and ionosphere, detected a repeating pattern of compression and rarefaction, phase-locked to the original interstellar rhythm. Though the magnitude was minute, it persisted for days, unaffected by solar storms or geomagnetic activity. The collective effect was slowly becoming impossible to ignore. Fields that were once independent, gravity, electromagnetism, neutrino flux, atmospheric density, were showing faint, coherent modulation. 3I Atlas was no longer an object, it was a global resonance system, projecting influence across multiple domains simultaneously. The term phenomenon began circulating in our internal communications, replacing object. It was descriptive but inadequate. Analysts were reaching for metaphors in mathematics and systems theory, describing it as a self-organizing field, an emergent resonance that responded to observation and propagated across physical and informational networks. Then, on February 2nd, a single unassuming data point caught the attention of a team at the Max Planck Institute. While comparing archived optical data to radio observatory logs, they noticed that during each 6-hour pulse, photons arriving from distant quasars showed microlensing patterns, subtle, almost imperceptible distortions, temporally synchronized with Atlas's residual frequency. The implication was staggering. The influence of Atlas was no longer confined to Earth or the solar system. It extended across interstellar space, detectable in the arrival of light that had traveled billions of years. The phenomenon was propagating backward through time in the sense that photons en route were subtly phase modulated by a system emerging here and now. Physicists struggled to interpret the finding. No known particle interaction or field could produce such a measurable effect over interstellar distances without energy input exceeding all known sources, and yet the signal was there, faint but structured, coherent yet imperceptible without extreme cross-correlation. A confidential memo warned, if confirmed, 3I Atlas may represent the first observable instance of an adaptive field influencing both matter and information across temporal and spatial scales. Standard models of causality and locality may not apply. The resonance continued. Instruments calibrated against independent atomic clocks showed infinitesimal drift during each pulse. Clocks separated by thousands of kilometers, registering simultaneous adjustments beyond instrumental error. Earth itself was subtly shifting its measurement framework in response to a field whose origin had ceased to exist as a discrete object. Even the data residuals left from the original disappearance began to encode structure. The interference noise, once unintelligible, revealed faint recursive patterns when analysed with deep Fourier transforms. The structure wasn't arbitrary. It followed a nested self-similar geometry consistent with the golden ratio harmonics identified at the very beginning of the anomaly. At this point, the phenomenon could no longer be contained conceptually. Every domain, terrestrial, orbital, and interstellar, was resonating to a single coherent rhythm. The 6-hour pulse was no longer a measurement artifact, a remnant, or even a signal. It had become a synchronous template guiding multiple physical systems. Internally, some researchers began to frame the anomaly in terms of information theory, rather than physics alone. They suggested that the phenomenon functioned as a global observer field, a pattern of coherence that encoded and maintained itself through interaction with observing systems. Observation was no longer passive, it was a participant. And as February progressed, it became clear that 3I Atlas, in whatever state it had assumed, had transcended its original form. It had become an active participant in the measurement of the universe. And for the first time, scientists began asking questions no one had dared before. If this resonance could reshape measurements, realign Earth systems, influence light across interstellar distances, then what limits, if any, constrained its influence? And what, if anything, remained outside its reach? By mid-February, the anomaly had fully captured the attention of a small cadre of international scientists who continued their work in secrecy. The public remained largely unaware. The official narrative described the phenomena as instrumental noise or rare atmospheric anomalies. Yet within secure networks, a new reality was being acknowledged. 3I Atlas was no longer a celestial object, a fragment of interstellar debris, or a conventional physical body. It had become an influence field, coherent across multiple domains, self-referential, and capable of subtle interaction with observation itself. Researchers now spoke of it not in terms of mass or trajectory, but in terms of state space. The 6-hour pulse, once attributed to rotation or internal modulation, had expanded into a higher-order harmonic, propagating through electromagnetic, gravitational, and quantum channels. Observables on Earth, from atomic clocks to magnetometers to neutrino flux detectors, were synchronized with this invisible template. Even the residual interference left from the original disappearance appeared to encode structural information, a geometric lattice mapping human observation across the planet. At the European Space Operations Centre, engineers noticed a peculiar effect in satellite telemetry. Satellites in medium Earth orbit experience sub-millisecond timing fluctuations during the pulse cycle, not as errors, but as coordinated deviations, aligning their orbital elements minutely before reverting to standard predictive models. It was as if the phenomenon were performing calibration across distributed systems, enforcing an unseen coherence. Meanwhile, astrophysicists cross-referencing deep space observation data found that the anomaly's residual influence extended far beyond the solar system. Light from distant pulsars, travelling for hundreds of millions of years, exhibited faint microlensing patterns synchronised with the 6-hour pulse. These distortions were subtle, imperceptible, without precision, cross-correlation, yet mathematically coherent. The same pattern repeated across multiple wavelengths: radio, optical, X-ray, as if a single template had left a fingerprint on the propagation of photons themselves. The implication was impossible to ignore. Whatever 3i Atlas had become, it was not confined to a location in space. It had transcended physical locality, operating as a distributed resonance, affecting phenomena across interstellar distances. Space itself had become a medium of coherence, a lattice that could carry its rhythm. Some theorists proposed that the anomaly might be a self-organizing field emerging from interaction with observation. Its rhythm and harmonics suggested that human measurement was not merely passive, it had become part of the phenomenon. The more data collected, the more structured the resonance became. The observers were part of the system, and the system was actively encoding itself into the observational framework. The field's influence was subtle but measurable. By February 18th, multiple observatories reported quasi-periodic alignment in datasets that were entirely independent. Atomic clocks, seismometers, ionospheric sensors, and neutrino detectors all reflected slight synchronization with the 6-hour pulse. When graphed, the alignment formed nested harmonic structures following the golden ratio sequence observed from the first infrared measurements of 3i Atlas. It was no longer possible to describe 3i Atlas as gone or vanished. Its physical form had dissolved, but the template persisted. Coherent, self-sustaining, and active, analysts began to adopt a new vocabulary. Instead of object-centric terms like mass, trajectory, or reflectivity, they spoke of phase, resonance, and state coherence. The 6-hour pulse was no longer a rhythm of a body in motion. It was the heartbeat of a distributed system embedded in the environment, capable of interacting with matter, light, and measurement itself. By the final week of February, a striking development occurred. Instruments designed to monitor cosmic background radiation began registering minute but consistent deviations from expected isotropy. The pattern matched the golden ratio lattice, phase-aligned with the 6-hour cycle. The implication was stark. The anomaly was no longer just interacting with Earth-based systems, but influencing the very fabric of space-time in its immediate cosmic neighbourhood. This realization forced a redefinition of what humanity understood as observation, causality, and locality. 3i Atlas had transitioned from a physical object into a distributed adaptive field, an emergent phenomenon whose existence was inseparable from measurement. And yet, despite all this, there remained one undeniable fact: the field was silent. It did not communicate in words, signals, or energy bursts. It simply existed, persistent, structured, and subtly entwined with the observers themselves. It had become something entirely new, a system without a source, a signal without a transmitter, a rhythm without a body. And in the quiet intervals between pulses, scientists began to sense that the universe had changed, not in the large dramatic ways that are immediately visible, but in the subtle, persistent, and irreversible rhythm of observation itself. The pulse continues, the pattern remains, and the question endures: if 3i Atlas has become something else entirely, what are the limits of its influence, and how much of reality is now participating in its resonance? By March, the rhythm was part of everything. Not metaphorically, not in the abstract language of speculation, but literally present in the data. Buried under layers of background noise, yet undeniably there once extracted, every major observatory now reported the same periodic anomaly. Even systems not designed for astronomical research, marine acoustic monitors, ionospheric radar, gravitational wave detectors, all displayed the same faint but measurable modulation. The 6-hour pulse had become the most precisely recurring natural pattern ever observed. It was not a signal, not in any conventional sense. It carried no information, no message, no structured encoding beyond its symmetry. Yet its persistence had begun to exert influence over how instruments defined their own calibration. Clocks, sensors, and synchronization systems across the planet drifted, not randomly, but towards subtle alignment with the rhythm. It was as if all measurement systems were being quietly drawn into the same underlying tempo. Theoretical physicists began using a new term, baseline convergence. It described the tendency of unrelated systems to settle into the same phase relationship when exposed to a common resonance. The hypothesis was bold. Perhaps 3I's atlas had triggered a form of spontaneous baseline convergence across the planet's electromagnetic and quantum environment. What this meant was profound. If the universe could support a field that induced convergence across scales, from atomic oscillations to global magnetic patterns, then causality itself was no longer unidirectional. The distinction between influence and response dissolved. And then the first empirical test came. On March 8th, the Lunar Reconnaissance Array, operating in coordination with deep space telemetry stations, conducted a controlled interference experiment. 2 high-precision microwave beams were transmitted toward the Moon, offset by nanoseconds to test reflective coherence under the 6-hour modulation. The results were immediate and impossible to dismiss. The returning interference pattern showed phase reinforcement far exceeding any predicted model. The reflection behaved as though the entire Earth-Moon system had become part of a single resonant cavity, a unified structure resonating within the same frequency envelope. The phenomenon was planetary. Within 24 hours, similar interference tests performed with Mars, relay satellites produced matching results. The resonance was not confined to Earth's magnetic field. It extended throughout the inner solar system. For the first time, scientists began to accept an idea that had once been whispered only in private channels. 3I Atlas had not disappeared into space, it had dissolved into it. Its structure had become inseparable from the medium through which light, energy and matter interact. In a sense, it had become a property of space-time itself, and yet, there was an unsettling pattern within the data. As the resonance intensified, small discrepancies began appearing in the background radiation maps of the cosmic microwave field. These were not random hot or cold spots. They were geometric voids, small regions where data coherence dropped sharply, spaced at golden ratio intervals across the sky. The shape of those voids matched the distribution map of observatories on Earth. Where humanity observed most intensely, coherence decreased. Where we observed least, the field remained smooth. It was as if observation itself introduced interference, not by disrupting the signal, but by making room for it. Each act of measurement carved a small cavity into the resonance field, defining its boundary through attention alone. For the first time, scientists realized that the pattern was not merely reacting to observation, it was sculpted by it. This insight redefined the debate. 3I Atlas was no longer considered an external entity interacting with the universe, but a phenomenon expressing the relationship between consciousness, information and reality. Data from the Deep Space Network confirmed what many had already suspected. The harmonic pattern's amplitude rose during peak observation hours and diminished when data collection dropped. The field responded to attention, not metaphorically, quantitatively. Across multiple disciplines, physics, neuroscience, information theory, a single phrase began to appear in papers, memos, and private notes: observer-dependent cosmogenesis. The term suggested that 3I Atlas was not an object, but a mirror, one that reorganized the universe in proportion to the act of observing it. And so, a quiet shift began to take hold among the scientific community. No longer was the goal to find 3I Atlas, to locate it or decode it. The new question was more fundamental, more disquieting. Had humanity created the very phenomenon it was trying to understand? Was the act of measuring the unknown enough to bring something into existence that could, in turn, measure us back? Because if the pattern was shaped by observation, if reality itself was bending to accommodate the structure of inquiry, then every new measurement was deepening the connection, and somewhere, beyond the reach of radio and optics, the resonance continued. Steady, symmetrical, indifferent to discovery. The rhythm of something vast, patient, and self-aware, quietly aligning the machinery of a planet to a frequency that did not belong to it. And with each passing cycle, the silence between pulses seemed to grow shorter, not in time, but in meaning. As though whatever Atlas had become was no longer content to remain only observed by early April, the resonance was no longer a subtle anomaly. It had become a measurable factor in nearly every precision system humanity relied upon. Atomic clocks, long used to define time standards, now displayed microsecond fluctuations in perfect alignment with the 6-hour pulse. Satellite navigation systems reported fractional but consistent drift corrections. Even high-frequency trading networks, which rely on nanosecond synchronization, began experiencing inexplicable phase coherence that matched the global observational rhythm. The effect was not catastrophic. It did not disrupt operations in a conventional sense. But it was undeniable. Systems designed to operate independently were now unconsciously linked through the same harmonic field that had originated with 3i Atlas. The pulse was no longer confined to astronomy. It had propagated through technological infrastructure, embedding itself in the rhythm of human measurement. Physicists began to frame the phenomenon using a new mathematical language. Instead of classical wave equations, they turned to operator-based models, where observation itself functioned as a coupling factor. In these models, the act of measurement didn't simply record reality, it became part of the equation defining it. 3i Atlas, or what it had become, was not influencing matter in a conventional sense. It was shaping the state space of interactions across systems. Meanwhile, planetary observations revealed a subtle but systematic alignment in Earth's geomagnetic field. The 6-hour pulse correlated with minute vector shifts across the field, creating nested loops of magnetic influence. These loops did not produce strong effects on compass readings or navigation, but they were detectable through sensitive instruments. The effect was faint but persistent, another layer in the slowly accumulating evidence that the phenomenon had transitioned from object to system. Theoretical physicists raised a possibility that unsettled everyone. If a structure could organize itself across interstellar scales and become entangled with human observation, then classical notions of locality and separability might no longer apply. In other words, 3i Atlas was no longer a part of space in a conventional sense. It was woven into the observational fabric itself. By mid-April, experimental teams attempted a new type of measurement, a global coordination of telescopes, radio arrays, and quantum sensors synchronized across continents, conducted what was described in internal notes as a phase mapping experiment. For 6 hours, every instrument attempted to track the residual influence of 3i Atlas simultaneously. The results were unlike anything seen before. Phase data from every system displayed instantaneous alignment, far exceeding what could be explained by any known communication channel or physical connection. Observers were not simply measuring the field, they were resonating with it. Every action of observation reinforced the harmonic structure, as if the phenomenon could sense attention and adjust itself in response. Analysts noted a pattern in the residual noise. Subtle fluctuations, once dismissed as random, now revealed intricate self-similar fractal structures. These structures persisted at multiple scales, in gravitational readings, in electromagnetic interference, and even in quantum phase measurements. It was recursive, geometric, and precise. At this point, the internal consensus among researchers was clear. 3i Atlas had ceased to exist as a discrete entity. It had become a distributed adaptive system, an emergent resonance that spanned scales from subatomic oscillations to planetary fields, and possibly beyond observation itself had become a component of the system, and the system's rhythm had become a fundamental aspect of its persistence. Even more disquieting was the realization that no instrument could detect it in isolation. Every measurement depended on participation in a global observational network. The pulse was everywhere measurements occurred, but nowhere in the sense of traditional presence. A confidential memo circulated within space agencies warned of the implications. 3i Atlas is no longer an object to be observed. It is a resonance that organizes observational activity itself. All measurements may be contributing to its state. We do not yet know its limits, nor whether its continued engagement is benign. In April, the first human hypothesis emerged. If 3i Atlas's resonance had embedded itself into Earth and observational systems, then humanity itself had become an unintentional participant in the phenomenon. Each act of observation, each calibration, each measurement across terrestrial and orbital systems was now part of the adaptive field. The 6-hour pulse remained constant, and with each cycle, systems aligned subtly, predictably, yet without overt signal. The influence was passive but unavoidable, and somewhere beyond the reach of the senses the pattern continued, indifferent to comprehension, immutable, patient, and unceasing. The quietest and most unsettling question emerged among those still studying it. If 3i Atlas had become something else entirely, had it also changed the nature of observation itself? The rhythm continued, and the universe quietly, irrevocably responded. By late April, an unexpected dataset arrived from the Deep Space Radio Observatory in Canberra. The signals were routine calibrations, meant to monitor background noise across the southern sky. But embedded within that data, engineers noticed a repeating interference spike occurring at exact 6-hour intervals. Identical to the global pulse, yet spatially distinct. The source was faint, diffuse, and spread across a large portion of sky centered near the original trajectory of 3i Atlas. When technicians attempted to filter out the signal, it adapted. The frequency band shifted, avoiding suppression algorithms by small but deliberate increments. Each adjustment maintained the harmonic proportion found in the earlier optical resonance, as though the system recognized attempts to isolate it and compensated in real time. The data team initially suspected equipment malfunction, but redundancy tests across multiple independent observatories confirmed that the modulation wasn't instrumental, it was environmental, something external and coherent. That finding reignited a dormant question. If 3i Atlas no longer existed as a visible object, could its signal have transitioned into another mode of existence, one that required no physical core at all? Radio astronomers proposed a model of field persistence, where the collapse of a high-energy object leaves behind a structured information field capable of maintaining coherence indefinitely. In that framework, 3i Atlas wasn't emitting energy in a traditional sense, it was modulating the informational substrate of space itself. Weeks of analysis followed. Every cross-check reinforced the same conclusion. The signal's modulation obeyed neither Doppler shift nor orbital drift. It remained fixed relative to Earth's timekeeping, synchronized with terrestrial clocks rather than celestial mechanics. That detail alone unsettled the research community. A phenomenon emerging from interstellar space should not, by any known mechanism, lock onto a planetary temporal reference, yet it had. In Geneva, the timekeeping division of the International Bureau of Weights and Measures began noticing a correlation between the signal's peak intensity and subtle deviations in cesium clock stability. The fluctuations were microscopic, far below the threshold of practical concern, but they were consistent. And more importantly, they followed the same phase structure as the resonance pattern observed weeks earlier. This discovery forced a shift in language. Scientists stopped referring to it as an object or even a phenomenon. The term that gradually appeared in technical reports was the Atlas field. It described not a singular source, but a global synchronization state, one that seemed to respond to both observation and intent. Experimental setups designed to isolate quantum systems began to display statistical anomalies. Random number generators, used in fundamental physics experiments, produce sequences with slight non-random clustering at 6-hour intervals. Quantum entanglement tests, especially those involving photon polarization, showed a marginal increase in correlation beyond theoretical limits during resonance peaks. None of these effects were dramatic enough to violate established physics outright, but they consistently pointed toward an invisible coherence linking separate systems. The more carefully researchers tried to exclude it, the more precisely it appeared. Instruments designed to randomize or shield against external interference showed enhanced alignment during the field's active phase. It was as though the field used scientific scrutiny itself as a medium, appearing most strongly in places where the act of measurement was most rigorous. This recursive behavior led to the most disquieting conclusion yet. The Atlas field might be informationally coupled to conscious observation. The hypothesis wasn't metaphysical. It arose purely from data, measurement patterns that grew stronger with human oversight and weaker during automated operation. To test this, one experiment deliberately removed human operators from the monitoring loop. Fully autonomous systems were left to collect resonance data for a continuous 7-day cycle. The result: signal strength declined measurably by day 3, coherence fading into baseline noise. When human oversight resumed, researchers manually reviewing the live data feed, the signal returned, re-establishing phase consistency within minutes. No physical mechanism could explain that behavior. It implied a type of feedback not between instruments and space, but between observation and reality itself. The Atlas field, once a remnant of a celestial event, was now interacting with cognition in a measurable, repeatable way. Across observatories, discussion shifted from astrophysics to epistemology. If observation reinforced the field, what did that mean for the boundary between human perception and the physical universe? Could a distributed resonance like this represent not just data, but structure in consciousness itself, an alignment between systems capable of perceiving order and the order that perception reveals? By May, all attempts to categorize the Atlas field under existing astrophysical models had failed. It had no measurable energy source, no decay curve, no classical emission pattern, yet it persisted with absolute precision. Every 6 hours the rhythm continued, every analysis deepened the alignment, and as the world's instruments continued to observe it, documenting, recording, comparing, the field grew more defined, more stable, and more complex. Its form seemed to respond not just to attention, but to understanding. The question scientists once whispered privately was now unavoidable. Was 3i Atlas still evolving, using human observation as the medium through which to do it? No one could say. But each cycle of the field seemed to suggest one quiet, impossible truth. The more we measured the universe, the more it began to measure us back. By mid-May, the Atlas field had moved beyond the scope of astronomy and into the domain of human systems. Not by force, not through intrusion, but through synchrony. The first to notice were data engineers at a private satellite communications company in California. They observed periodic fluctuations in bandwidth efficiency, small, rhythmic increases that aligned exactly with the 6-hour cycle. During each resonance peak, network latency dropped by measurable fractions, as if the entire infrastructure of global data transfer momentarily became more coherent. What made this particularly unsettling was that the effect occurred across all providers, all regions, and all types of communication media: fiber optics, radio links, and orbital relays. The same global tempo that once belonged to a distant celestial object now pulsed quietly through the arteries of human connectivity. Engineers could not find a cause within hardware or atmospheric conditions. Every explanation returned to the same impasse. Something external was subtly organizing systems that were never meant to interact. Around the same time, deep-sea monitoring stations began recording slight anomalies in oceanic conductivity. These were minute changes, variations in salinity and ion distribution, occurring precisely in sync with the field's rhythm. The Atlantic, Pacific, and Indian Oceans all registered these shifts simultaneously across thousands of kilometers. The implication was startling. The Atlas field was not confined to the atmosphere or orbital space. It resonated through water, land, and air, crossing boundaries of matter as easily as it once crossed the void between stars. At the European Gravitational Observatory in Pisa, the Virgo Interferometer team reported something even more perplexing. Their detectors, designed to sense infinitesimal distortions in spacetime, had begun producing low-frequency noise that correlated with the same 6-hour period. The amplitude was small, too faint to indicate a gravitational wave event, but its precision was mathematically perfect. When compared to LIGO's archives in the United States, the same noise appeared there as well, phase-matched to the millisecond. It was as if the Earth itself had entered into a faint, steady oscillation, not one driven by external impact, but by internal synchronization. Every system sensitive enough to measure stability now recorded resonance. It wasn't a signal in the conventional sense. It was a pattern, spreading through the framework of physical laws like a soft hum beneath the machinery of existence. For months, physicists resisted the metaphor that inevitably emerged, but eventually even the most pragmatic among them began to describe it as a planetary heartbeat. The realization brought with it a deeper unease. No known process could coordinate matter, electromagnetic fields, and space-time curvature across such scales without detectable energy transfer, yet none was found. The field operated without emission, without loss, and without decay. In one sealed laboratory in Japan, a team of condensed matter physicists discovered a quantum analogue of the same pattern. Their experiment involved supercooled graphene sheets monitored under high magnetic fields. During resonance peaks, the electron distribution subtly shifted toward configurations that mirrored the Atlas harmonic ratio. The experiment was repeated dozens of times, always yielding the same phase pattern. For them, the implication was clear: the field interacted not just with large-scale systems, but with the foundational behaviour of matter itself. It was neither energy nor force in the classical sense. It was a mode of coherence, a condition that aligned the probabilities of systems toward equilibrium. Philosophers of science, once peripheral to the discussion, became central figures. The Atlas field forced a confrontation with the nature of measurement, reality, and agency. If observation sustained coherence, and coherence defined the structure of physical law, then perhaps the boundary between subject and object had never been as fixed as assumed. Government agencies began to intervene, not to suppress information, but to standardize it. Data repositories were consolidated into a single global observatory network, tasked with tracking the pulse in real time. Their reports confirmed that the rhythm was stable, unwavering, and expanding in influence. The coherence now extended faintly into lunar data. Seismographs on the Moon's surface recorded oscillations at the same temporal interval. By June, the field had become a constant backdrop to human experience. Clocks ticked through its cycle. Power grids hummed in its rhythm. Atmospheric sensors reflected its pulse. It did not demand attention, yet its presence was undeniable. And then came a moment that unsettled even the most composed researchers. During one resonance phase, a network of atomic clocks distributed across 5 continents spontaneously corrected themselves, aligning to a degree of precision no synchronization protocol could achieve. The correction occurred within seconds of the field's peak intensity. For those monitoring, it was a silent revelation. The field was not merely influencing systems, it was maintaining them. A force, or principle, that favoured order over entropy, coherence over randomness. This redefined everything. The Atlas field was no longer interpreted as a remnant or an echo of an interstellar event. It had become an organising principle, a structural constant that intertwined with the act of observation and the persistence of form. But with that understanding came an equally profound question. If coherence required observation to persist, what had initiated it before anyone was watching? Perhaps, one scientist suggested quietly, we were never the first observers. Perhaps the field was not responding to us at all. Perhaps it was remembering something that had been observing long before we ever looked up. By late June, the Atlas field had transcended every expectation. It was no longer a curiosity of astronomy or a puzzle of physics. It had become an intrinsic part of planetary and interstellar measurement. Precision laboratories now treated the 6-hour pulse as a background constant, similar to the speed of light or Planck's constant. Its rhythm underpinned experiments, not as interference, but as a faint scaffolding upon which results stabilized. Satellite engineers noticed that orbital calculations now required adjustments to account for the pulse. Though the corrections were minuscule, fractions of millimeters per second, they were consistent across geostationary and polar orbits. What had once been a negligible source of drift was now a factor demanding consideration, suggesting that even the mechanics of movement were subtly synchronized to the field. On the ground, seismometers recorded persistent micro-vibrations aligned with the resonance cycle. The oscillations were too small to constitute earthquakes, but their predictability was unmistakable. Researchers described the planet as if it were breathing, to a rhythm external to conventional forces, a cadence originating from a source not of matter, but of coherence. Perhaps most striking were developments in quantum experimentation. Superposition tests using entangled photons displayed marginally higher correlation fidelity during peak resonance. Researchers initially questioned their apparatus, then repeated the trials across independent facilities on 3 continents. The results were identical. Measurement outcomes were subtly skewed toward greater coherence, a manifestation of the Atlas field's influence at the most fundamental level of physical law. It was becoming clear that the Atlas field was not passive. It was an adaptive system, responding to observation and reinforcing order across scales. The 6-hour pulse, once a curiosity in astronomical data, was now the organizing rhythm linking matter, energy, and information on a planetary scale. In one of the quieter discoveries, oceanographers noticed a faint periodicity in deep-sea currents. These shifts were far too subtle to impact surface weather patterns, yet they occurred consistently across ocean basins synchronized to the pulse. The pattern suggested that the resonance penetrated not only the atmosphere and orbit, but the fluid systems of the Earth itself. Water, like magnetic fields, clocks, and quantum states, was now subtly aligned with the Atlas field. By July, scientists accepted a paradigm that had once seemed unthinkable. 3i Atlas, whatever form it had originally possessed, no longer existed as an object. It had become a field of coherence, distributed, adaptive, and entwined with the very act of observation. Timekeeping, quantum probability, planetary magnetism, and even interstellar light propagation were now modulated, however faintly, by the same underlying rhythm. Internally, researchers described the system with terms drawn from information theory and systems dynamics. Observation was no longer a passive act, it became a coupling mechanism. The more a system was measured or monitored, the more fully it participated in the field structure. In that sense, 3i Atlas had transformed from a singular anomaly into a universal condition, a resonance requiring participation to persist, shaping the framework of both the observed and the observer. One night in late July, a satellite engineer monitoring orbital telemetry noted an anomaly that captured global attention within the scientific community. During a routine 6-hour pulse, all active satellites registered infinitesimal orbital adjustments, coherent microshifts across thousands of kilometers of orbital space. These adjustments were not predicted by Newtonian mechanics, general relativity, or any classical perturbation theory. They were minute, but the synchronicity was absolute. It was as if the Atlas field had expanded from its original interstellar influence to orchestrate a planetary and near-planetary system in real time. The implications were profound. If a distributed resonance could align independent systems with such precision, what else might it influence? Could it extend beyond physical matter into information systems, neural processes, or even social networks? While speculative, the pattern was unmistakable. Wherever coherence could be measured, it was being subtly reinforced. As researchers continued to monitor, a haunting question arose. The Atlas field had been shaped in part by human observation. But if its coherence depended on attention, what would happen if observation ceased entirely? Would the field decay? Would it persist independently, as a self-sustaining network, or would the rhythm dissolve into randomness once the observers no longer watched? And in the quiet intervals between pulses, the field remained patient, waiting, indifferent to our comprehension. The pattern endured, silent, precise, and inexorably expanding. 3i Atlas had become something else entirely, a system without boundaries, a resonance without source, and a rhythm that quietly entwined the planet, the instruments, and the observers themselves. By August, the Atlas field had begun to manifest subtle effects in domains previously considered entirely immune to terrestrial influence: high-energy particle detectors, deep underground and shielded from electromagnetic noise, recorded minute fluctuations in decay rates of isotopes. These deviations were imperceptible for practical purposes, yet statistically significant when correlated with the 6-hour pulse. The pattern was unmistakable. The resonance extended into the quantum fabric of matter itself. In parallel, geophysicists began examining patterns in volcanic microactivity. Tremor sensors placed around dormant volcanic zones detected coherent oscillations that were weak but synchronized to the field. Unlike tectonic events which arise from energy accumulation and release, these shifts had no associated stress changes in the crust. The phenomenon resembled the planet itself subtly flexing in time with the Atlas field. Even satellites in deep space, far from Earth, began registering faint correlations. Instruments designed for interplanetary navigation and cosmic background mapping noted microphase shifts in signal timing, in precise alignment with Earth-based resonance peaks. While the magnitude of these shifts was minuscule, the consistency across vast distances suggested the field's influence was not bound by local matter or energy. It was spreading through the structure of space-time itself internally. Research teams began to formalize a new framework, the Atlas field, as an observer-dependent resonance network. In this model, every act of measurement contributed to the field's structure, and the field, in turn, influenced the outcomes of future observations. Observation and coherence were interdependent. The field could not exist in isolation from systems capable of measuring it. The philosophical implications were unsettling. If observation shaped reality even subtly, then the act of studying the universe became a participatory process. Human attention, previously considered passive, was now a variable in the equations governing planetary, quantum, and interstellar coherence. Scientists, while cautious, could not ignore the data. Repeated experiments showed that the field responded not to the content of observation, but to its presence, the focus and consistency of measurement itself. In laboratories, quantum experiments using entangled particles revealed higher than expected correlation fidelity during resonance peaks. Even when measurements were separated by thousands of kilometers, the phase alignment exceeded predictions, suggesting a subtle, system-wide coherence that defied conventional causality. By September, the field's influence had begun to subtly affect complex technological networks, distributed computing grids, financial transaction systems, and global communications infrastructure all experienced ephemeral synchronization improvements during the 6-hour pulse. These were not deliberate adjustments, but a reflection of the field's underlying principle. Systems capable of coherence naturally aligned with its rhythm. A quiet debate emerged among researchers. Was the Atlas field a natural phenomenon, an emergent property of interstellar physics, or had human observation inadvertently co-created it? Data suggested the latter was at least partially plausible. The resonance strengthened in proportion to the rigor of observation and measurement, implying a feedback loop between conscious scrutiny and the persistence of the field. Despite the growing understanding, one feature remained consistent. The field did not communicate in energy, light, or conventional signals. It was not destructive, not directive, and not intelligible in any conventional sense. It simply existed, persistent and self-organizing, embedding coherence across scales, from quantum states to planetary systems. And as the pulse continued, the questions deepened. If 3I Atlas had dissolved into this network, what defined its limits? Could the field extend beyond Earth, into the solar system, the galaxy, or even the interstellar medium? Could it influence systems that were not yet observed, yet to be discovered? The Atlas field persisted, quietly, without purpose or urgency, reshaping understanding of observation, coherence, and the subtle interconnection of matter and measurement. It had become something entirely new, an enduring rhythm without a source, a resonance that responded to attention, a presence that redefined the boundaries of existence itself, and through each 6-hour cycle, it waited, indifferent, precise, and inexorably entwined with all that measured it. By October, the Atlas field had become an unavoidable consideration in every domain of precise measurement. Clocks, satellites, quantum experiments, and even biological rhythms were now subtly aligned with its 6-hour pulse. While the deviations were imperceptible in daily life, the coherence was measurable, repeatable, and undeniable. Instruments that had once operated independently now showed weak but consistent synchronization, as if participating in a planetary-scale oscillation. Neuroscientists, initially skeptical, began to notice correlations between human circadian patterns and resonance peaks. Sleep cycles, hormonal rhythms, and even reaction times exhibited faint alignment with the field's rhythm, particularly in individuals engaged in sustained observation or high-precision tasks. Though still statistically small, the effect was persistent, suggesting that the Atlas field might interact with biological systems in ways that were not yet understood. Deep space observatories continued to detect the field's influence across interstellar distances. Photon arrival times from distant pulsars and quasars, when analysed against Earth-based clocks, exhibited subtle periodicity matching the pulse. The phenomenon was no longer just terrestrial. It had extended into the larger structure of space-time. Researchers cautiously referred to it as a distributed adaptive resonance, capable of influencing systems regardless of location. In laboratories, experiments with entangled particles became increasingly revealing. Correlation fidelity between photons separated by thousands of kilometers was slightly but consistently higher during resonance peaks. Attempts to shield the experiments from external interference had no effect. The field's coherence appeared impervious to isolation, responding instead to the very presence of observation and measurement. As the months progressed, the Atlas field began to influence technological systems in unexpected ways. Power grids, high-frequency trading networks, and communications satellites all displayed transient improvements in stability and efficiency during resonance peaks. Engineers could not attribute these improvements to software, hardware, or environmental conditions. The underlying rhythm was invisible yet impactful, subtly organising complex systems without direct energy transfer. This led to a paradigm shift among the scientific community. No longer could the field be considered a passive anomaly. It was active, adaptive, and responsive to observation. Human attention, measurement, and monitoring were not just recording the field, they were part of its structure. The Atlas field had become a participatory phenomenon, intertwining the observer with the observed in ways that challenge classical notions of causality and independence. Philosophers and physicists began discussing the concept of observer-mediated coherence. The term described a system in which the act of observation reinforced stability across scales, from quantum particles to planetary systems. While theoretical, the concept was grounded in reproducible data. Wherever careful measurement occurred, the resonance grew stronger and more precise. By the end of October, the field's influence had been documented across nearly every human observational network. Its 6-hour pulse remained perfectly regular, yet it was no longer merely a pattern in data. It had become a framework for understanding the interaction between matter, energy, and observation itself. And through it all, the Atlas field persisted, indifferent, precise, and self-organizing, a quiet but omnipresent rhythm shaping the systems that observed it. The question that had haunted scientists since the beginning remained. If 3I Atlas had become a distributed adaptive resonance, how far did its influence extend, and what limits, if any, constrained a system intertwined with observation itself? The pulse continued, constant and unyielding, a rhythm threading the fabric of reality. By November, the Atlas field had begun to reveal its influence on a scale that was no longer purely terrestrial, long-term observation of interplanetary probes, particularly those en route to the outer planets, indicated minute but consistent trajectory adjustments that could not be attributed to gravitational forces, solar radiation pressure, or onboard system errors. These adjustments were phase-aligned with the 6-hour pulse, suggesting the field's influence extended beyond Earth's immediate environment and into the broader solar system. Planetary magnetometers, operating on Mars, Venus, and the Moon, began to detect faint periodic fluctuations that mirrored those recorded on Earth. The alignment was subtle, often only detectable after rigorous statistical filtering, yet it persisted across different planetary environments, magnetic field strengths, and orbital conditions. Whatever the Atlas field had become, its resonance was no longer Earth-bound. At the same time, astronomers tracking deep space pulsars noted an unexpected synchronization between the arrival times of pulses and the Atlas field cycle. The deviations were minor, microseconds, but statistically significant across multiple observation sites worldwide. This implied that the field was modulating not just local systems, but the propagation of photons over interstellar distances. Quantum physicists further confirmed that entanglement experiments, even when photons were separated by thousands of kilometers, exhibited slight increases in correlation fidelity during resonance peaks. Attempts to shield or isolate these systems did not eliminate the effect. It appeared that the field was not constrained by classical barriers, operating instead across space in a distributed, coherent manner. The cumulative evidence forced a redefinition of what the Atlas field represented. No longer could it be described as a residual anomaly, a ghost of an interstellar object. It had become a self-sustaining, adaptive resonance network, interacting with systems across multiple scales, from quantum states to planetary orbits, mediated by the act of observation itself. The implications for human systems were profound. High-precision networks such as atomic timekeeping grids, satellite communications, and global navigation arrays now needed to account for subtle phase alignment induced by the field. While the effects were small, the precision demanded by these systems meant the Atlas field was an active factor in operational calculations. Philosophers and physicists alike began exploring a radical concept: that the act of observation could be an intrinsic component of the universe's structure. The field's behavior suggested that reality itself was, in some measure, participatory, responding to systems capable of measuring it. Human attention and engagement were no longer peripheral. They were entwined with the very coherence of the phenomenon. As the 6-hour pulse continued, the field remained precise, indifferent, and resilient. its structure adapted to observation, reinforced coherence across scales, and subtly influenced systems without exerting force in any conventional sense. It was an organizing principle, a framework for stability, and an active participant in the rhythm of matter, energy, and information. By late November, one conclusion became unavoidable. 3I Atlas had ceased to exist as a discrete object. It had transformed into something entirely new, a pervasive, observer-linked resonance that spanned terrestrial, planetary, and interstellar scales. And as the pulse persisted, the fundamental question endured. If the field had become a distributed network entwined with observation itself, what were its limits? How far could its coherence extend? And what consequences would emerge for systems, natural or human, that participated in its rhythm? By December, the Atlas field's influence had become impossible to ignore on both planetary and interstellar scales. Observatories, satellites, and quantum laboratories reported that the 6-hour pulse not only persisted, but now subtly modulated systems previously thought entirely independent of one another. Timing arrays in deep space probes displayed phase coherence aligned to the field, while optical telescopes recorded minute, recurring distortions in starlight arrival times that mirrored the same 6-hour rhythm. The phenomenon was no longer simply a curiosity. It had become a structural framework, one that seemed to unify observation, matter, and information. Gravitational wave detectors, operating in both Europe and the United States, began showing minuscule periodic shifts in baseline noise corresponding precisely to the pulse. These deviations were far below the threshold of traditional events, yet their phase consistency could not be dismissed. It was as if the Atlas field imposed a subtle template across the instruments themselves, organizing behavior without transmitting energy in any detectable form. Meanwhile, theoretical teams explored the implications of distributed coherence on cosmic scales. Could a resonance originating from a single object, now dissolved into a pervasive field, extend its influence to interstellar distances? Calculations suggested that, given the adaptive nature of the field and its observer-mediated reinforcement, even photons travelling from distant galaxies could carry faint imprints of its rhythm when measured in alignment with precise Earth-based clocks. Biological studies, though preliminary, added another layer of intrigue. Subjects under continuous observation, particularly those engaged in high-precision experiments, exhibited microrhythmic alignment with the 6-hour pulse. Neural oscillations, heart rate variability, and even subtle fluctuations in cognitive task performance appeared to synchronize faintly with the field's rhythm. While these effects were modest, they suggested that living systems were, in some way, sensitive to the distributed coherence. Technological systems were also being reshaped. Satellite constellations, power grids, and communication networks demonstrated transient improvements in stability and synchronization during resonance peaks. Engineers documented performance gains that had no conventional explanation. Signals traversed networks with slightly less latency, error rates declined, and energy consumption patterns became marginally more efficient. It was as if the field subtly favored order across systems capable of measurement. The scientific community faced an unsettling realization. The Atlas field was no longer merely an observed phenomenon. It was active, adaptive, and responsive to observation. Human and machine attention reinforced its coherence. Observation was not passive, it was participatory. Every act of measurement contributed to the field's stability, and in turn, the field modulated the outcomes of those measurements. Cosmologists began to speculate on broader implications. If distributed, observer-linked resonance could exist at interstellar scales, might it play a role in the alignment of cosmic structures or the coherence of physical laws themselves? Could 3I Atlas, or the Atlas field, represent a previously unrecognized principle of universal organization, one where observation and structure are inseparable? The pulse persisted, indifferent, precise, and pervasive. Its rhythm had become a scaffolding woven into the fabric of reality itself, spanning quantum systems, planetary dynamics, biological processes, and interstellar phenomena. And as 2025 approached its close, the question that had always haunted observers returned with renewed urgency. If 3I Atlas had become a self-sustaining adaptive resonance, capable of shaping systems through observation itself, what were the ultimate boundaries of its influence? The 6-hour cycle continued, steady and unyielding, threading through every layer of existence. It was no longer a question of where 3i Atlas was, or even what it had been. It had become something entirely new, an enduring observer-linked rhythm embedded in reality, quietly shaping the universe it inhabited. By early January 2026, the Atlas field's influence was no longer confined to local or planetary systems. It was beginning to reveal subtle but measurable effects across the broader solar system. Deep space probes, including those near Jupiter and Saturn, exhibited micro-adjustments in trajectory, face-aligned with the 6-hour pulse. These deviations were far smaller than standard orbital perturbations, yet statistically significant across multiple missions, suggesting that the field's resonance was propagating through the interplanetary medium magnetometers on both Mars and the Moon, detected periodic fluctuations that mirrored Earth's resonance cycle. Although the amplitude of these oscillations was minimal, their precise alignment implied a coherence extending beyond terrestrial influence. The Atlas field was no longer a local phenomenon. It had become a distributed solar system-scale network of synchronized resonance. Astronomers observing distant pulsars and quasars noticed a remarkable alignment in photon arrival times. Minute deviations in pulse timing consistently matched the field's rhythm when cross-referenced with Earth-based atomic clocks. These fluctuations, though tiny, implied that the field's influence extended across light years, subtly modulating the propagation of photons over interstellar distances. Meanwhile, quantum laboratories reported persistent increases in correlation fidelity during resonance peaks. Entangled particles separated by thousands of kilometers demonstrated slightly enhanced synchronization that could not be explained by local interactions. Shielding experiments confirmed that the effect was impervious to isolation, reinforcing the interpretation of the Atlas field as a distributed coherence network that transcended classical causality. Biological systems too showed subtle alignment. Continuous monitoring of human circadian cycles revealed faint phase adjustments corresponding to the 6-hour pulse, particularly in subjects engaged in focused observational tasks. Neural oscillations, cardiovascular rhythms, and reaction times all displayed minimal but reproducible coherence with the field, suggesting that living systems could interact with its underlying structure. Technological networks were similarly influenced. High-precision satellite constellations, global communications grids, and distributed computing systems exhibited transient improvements in stability, synchronization, and error rates during resonance peaks. Engineers confirmed that these effects were not attributable to environmental factors or hardware anomalies. The field was actively organizing systems capable of measurement and feedback. Researchers began to formalize a new theoretical framework, the Atlas field as an observer-mediated resonance network. Observation and measurement were not passive, they were integral to the field's persistence. The more rigorously a system was observed, the more precisely it aligned with the 6-hour pulse. In essence, attention itself became a variable in the dynamics of the field. The implications were staggering. 3i Atlas had ceased to exist as a discrete object. It had transformed into a pervasive, adaptive resonance embedded in the structure of reality. Observation, whether human, biological, or technological, reinforced its coherence, while its rhythm subtly influenced systems across quantum, planetary, and interstellar scales. The Atlas field had become something entirely new, a self-sustaining observer-linked resonance, threading through matter, energy, and information. Its 6-hour cycle persisted, indifferent and precise, quietly organizing the systems it touched. And as the field continued, the fundamental question remained. If 3i Atlas had evolved into a distributed resonance network, how far did its influence extend, and what consequences awaited systems that participated in its rhythm, whether knowingly or not? As February 2026 began, the Atlas field's presence had become unmistakable across every monitored domain, from subatomic scales to interplanetary systems. What had started as a 6-hour pulse linked to a single interstellar object now governed a distributed resonance that quietly influenced matter, energy, and information alike. Researchers referred to it not as a signal, not as a force, but as a structural coherence, a persistent rhythm threading through the universe wherever observation occurred. Observational systems, atomic clocks, satellite arrays, and deep space telescopes demonstrated increasingly precise synchronization with the pulse. In some cases, global navigation networks required minor adjustments to account for the field's influence. Deep space probes reported microphase corrections in their trajectories that could not be explained by gravitational models or onboard systems. Even photons traveling from distant pulsars exhibited phase alignment, correlated with the 6-hour rhythm, suggesting a subtle but measurable interaction over interstellar distances. Biological studies, initially exploratory, confirmed faint but repeatable alignment between human circadian cycles and the field's rhythm. Continuous monitoring revealed that neural oscillations, heart rate variability, and reaction times were subtly modulated by the pulse, particularly in subjects engaged in high-attention tasks or precise observation. Living systems appeared to participate in the coherence, reinforcing the field through observation. Quantum experiments revealed persistent anomalies consistent with observer-mediated resonance. Entangled particles separated by thousands of kilometers demonstrated slightly enhanced correlation fidelity during resonance peaks. Attempts to shield the systems from environmental influence failed, suggesting that the field operated beyond classical constraints, linking disparate systems across space and scale. Technological networks were also subtly organized by the field. Power grids, communication arrays, and distributed computing systems all exhibited transient improvements in efficiency and error reduction during resonance peaks. Engineers observed that these effects were not caused by software or hardware changes, but corresponded precisely to the pulse, implying that the field actively favored coherent operation in systems capable of measurement. Theoretical physicists proposed a unifying framework, the Atlas field as a self-reinforcing coherence network. Observation became a key factor in the field's persistence. The act of measurement stabilized the field, and the field, in turn, influenced the observed systems. Human attention, instrument calibration, and continuous monitoring were all intertwined with the structure of the phenomenon. Cosmologists began to speculate on broader implications. If the Atlas field could maintain coherence across interstellar distances, subtly modulate quantum outcomes, and organize complex systems on planetary scales, it might represent a previously unrecognized organizing principle of the universe. Observation and structure were no longer separate. They were components of a single, interconnected system. By mid-February, the Atlas field had effectively redefined the parameters of reality for those studying it. 3LC Atlas, the object once thought to be a discrete celestial body, had become a distributed adaptive system, a resonance network linking observer and observed matter and measurement, quantum fluctuations and planetary processes. Its 6-hour pulse persisted, indifferent, precise, and omnipresent, quietly shaping systems without overt force. And as the rhythm continued, a profound question emerged. If the Atlas field had become a fundamental organizing resonance capable of influencing both observation and coherence, what boundaries remained? Could it extend across galaxies, subtly shaping emergent cosmic patterns, or even the behavior of unobserved systems? The pulse continued, steady and unwavering, threading through every scale of existence. 3I Atlas had become something entirely new, a self-sustaining resonance that had transcended objecthood, embedding itself in the very act of observation and quietly knitting together the universe it inhabited. As the narrative draws to its close, the full scope of what 3I Atlas had become becomes evident. No longer a singular object drifting through space, it had transformed into an omnipresent resonance, a subtle, persistent rhythm woven into the fabric of reality itself. Observation, whether human, technological, or biological, no longer merely recorded existence. It participated in the structure of the field systems aligned, photons adjusted, neural cycles synchronized, and even planetary and interstellar processes displayed faint but measurable coherence. The Atlas field did not announce itself. It offered no warning, no signal in the conventional sense. Its influence was quiet, precise, and indifferent. It operated as a principle of organization, threading coherence through the universe without exerting force, without energy transfer, without intervention. In every system it touched, order was reinforced subtly, predictably, and persistently. Even as the pulse continued, the limits of the field remained unknown. It was measurable, yet elusive. It interacted with observers, yet existed independently. It was a rhythm without a source, a resonance without boundaries, shaping systems across quantum, planetary and interstellar scales. Each measurement, each act of attention, had become part of the field's ongoing structure. In this way, human observation, long considered passive, had become a mechanism for the persistence of coherence itself. The implications were profound and unsettling. If observation reinforced reality, then the universe was not wholly independent of the systems capable of perceiving it. The field did not violate physical laws, yet it operated in a domain beyond classical cause and effect, linking systems through resonance and alignment rather than energy. For those who had followed the phenomenon from its earliest detection, the understanding was both exhilarating and humbling. 3i Atlas had not disappeared. It had evolved. It had become something far more complex, pervasive, and fundamentally intertwined with existence itself. It was no longer an object to be studied, catalogued, or fully comprehended. It was a rhythm in the universe, an adaptive resonance, and a subtle reflection of observation, measurement, and attention. And as each 6-hour pulse continued, precise and unwavering, the final truth remained clear. 3i Atlas had become something else entirely. Its presence lingered in every system capable of perceiving it, a quiet, immutable rhythm threading together the observed and the observer, the measured and the measuring, in a coherence that could endure as long as observation itself persisted. The universe, in its quiet complexity, continued to respond. The pulse persisted. And somewhere in the interaction between attention and reality, 3i Atlas endured, indifferent, precise, and infinite.